In this video, we will be discussing some of the important updates made for Nastran, particularly Simcenter Nastran in Simcenter Femap 2022.1. The first update we will cover is the ability to request Simcenter Nastran to produce an output file, in particular an OP2 file, in a format which can then be used by Femap, other applications in the Siemens Simcenter portfolio, including Simcenter 3D, and other commercially available pre- and post-processors. To have Femap request output be placed into the OP2 file in this format, we will use the Analysis Set Manager, go to Output Requests, and once in the dialog box, simply select Simcenter under Results Destination, and that is all that is needed. Now Nastran knows to create the param post -2 entry in the input file. Should you want Femap to always create an OP2 file using param post -2, that can be done using the File Preferences command, going to the Interfaces tab, and selecting Simcenter for the Results Destination option. One additional thing to remember is that some pre- and post processors which can read OP2 files created using param post -1, which is the Femap default, require that the model information also be in the OP2 file, which is done by setting param OGM to a value of yes. By turning on the Activate OGM parameter in this same dialog box, all newly created analysis sets will have the OGM option turned on automatically. The next update we will discuss is support for tension-only quadrilateral shell elements, which has been added to the multi-step nonlinear solution sequence, Solution 401, for Simcenter Nastran 2022.1. The tension-only quad can convert from behaving like a shell element to instead behaving like a shear panel element based on a component direction and a compressible allowable, both specified by the user, which then creates a PSHLPNL entry in the Nastran input file. In Femap, the behavior of tension-only quad elements is controlled by specifying property extensions, which are available when defining a plate property. Simply select the Simcenter Autodesk Nastran tab, then specify which component direction to use for every quad element referencing that property, such as use X membrane stress or one of the other options. You will then also want to specify a value for compression allowable, which is used to determine when a shell element will start to behave like a shear panel. Once converted, the element retains shear panel behavior for the remainder of any sequentially independent subcase and any sequentially dependent subcases which follow. After the property extensions have been specified, the tense OQD parameter can be specified in the Analysis Set Manager to control the behavior of tension-only quads. By default, the ability to have shell elements convert to shear panel elements is active, but can be deactivated by turning on tense OQD and setting it to tension-only quad behaves as shell. In addition, anytime tension-only quad property extensions have been defined, the E shell PNL entry will automatically be added to case control of the Simcenter Nastran input file. Once the analysis has been completed, it is easy to visualize which elements have been converted to shear panel elements by displaying shear panel results. After looking at the shear panel results, it is also possible to look at the shell element results to see which elements were not converted to shear panel elements. Support for a new way to specify control options for the dynamic design analysis method, often called DDAM, has been added to Simcenter Femap 2022.1. DDAM is performed in 3 steps. First, Simcenter Nastran performs a modal analysis on the structure to calculate the modal participation factors and modal effective mass for each mode. Next, the Naval Shock Analysis Fortran program, NavShock, uses the modal effective masses and natural frequencies calculated by Nastran, along with user inputs, to compute shock design accelerations. Finally, Simcenter Nastran uses the shock designed accelerations along with the modal participation factors and natural frequencies to compute the shock response of the structure. The first thing needed within Femap to run a DDAM analysis is an analysis set specified to do a normal mode's eigenvalue solution. Once that has been specified, most everything else is controlled via the Nastran DDAM solution options dialog box. So the first thing you want to do is enable DDAM analysis, and then choose, if you choose DDAM, what that's going to do is that's going to run DDAM using the legacy method. So what this entails is the creation of multiple external files, and all of these options in here basically get written to a control file, which is then sent to the NavShock program. Now, if you want to use the new methodology, instead you choose ddam ctr/spdir instead. So now, instead of all of those controls being written to an external file, instead they are written to two Nastran entries, which will be included in the Nastran input file. So I'm just going to specify a value there, and then I'm just going to do a preview of the input, and you can see that the values are here for those particular Nastran entries. So once the analysis has been completed, you're going to get three output sets, which are the summed modal response in the X, Y, and Z directions, respectively. So we're just going to take a look at the summed modal Y response. So that's just a contour plot, and that's just an animation of the analysis.